Please Look Up is recorded in the Scitech Planetarium on Whadjuk Noongar land. Good evening, everybody, and welcome to Please Look Up, the monthly podcast produced by Particle, where we take you through a guided tour of the night sky as seen from Perth, as well as taking a deep dive into some of the more out-of-this-world space news. In this episode, we'll be discussing what you can see in the night sky in the month of June. My name is Leon, and I'm joined by Amanda, a professional presenter from the Scitech Planetarium. Amanda, thanks for being here.
Thanks for having me.
So let me start with a very basic question. If I'm outside just casually looking around in the evening sky, what sort of planets can I see in the month of June?
Yeah, well, if you're into planet spotting, it's definitely worth heading out at around sunset so you can watch the sun set and know you're facing west. And then up in the western sky, you'll see the planet Venus. So it'll look like the first star that's appearing in the night sky, which is why it's nicknamed the evening star, but you'll be able to point at it and know, oh, that's not a star, that is a planet Venus.
Ah, okay. I've definitely seen that. And so it's the evening star, is that the nickname?
Yes, it is. And then just over to the right of Venus in the northwest sky, we have Mars as well. It's a bit dim at the moment because Earth has travelled past Mars and we're quite far away from it in our orbit, but it is still up there. You might be able to just see it.
Oh, okay. So Venus and Mars in the west, but Venus is definitely the brighter one, the star of the show, for lack of a better word.
The one to look out for, definitely.
The one to look out for. Okay. Is it just those two planets this month?
Yeah, in the nighttime sky, definitely, unless you're staying up till about midnight to catch Saturn rising. Or if you're a particularly early riser, in the morning before sunrise, you should be able to spot Jupiter and Mercury in the east. Oh,
okay. Before sunrise. Yeah, I'm not a morning person, so I will not be doing that. Okay, so I know what planets I'm looking for now. What about any interesting constellations, any stars I should look out for?
Yeah, okay. Well, I have one interesting constellation you can head out and check out, which is the constellation Ophiuchus, which is the serpent-bearer. So Ophiuchus is a man carrying a serpent or big snake with him. Now, Ophiuchus lies on the celestial equator, so that actually means that it can be seen by observers in both the north and southern hemispheres.
Oh, is the celestial equator just like the imaginary projection of Earth's equator up into space?
Yeah, exactly. So anything that lies along there, people anywhere on Earth will be able to see.
Okay, that makes sense.
Yeah. Now, it's also interesting, lies along the ecliptic. So planets do sometimes pass through the constellation, making it a zodiac constellation as well.
Oh, really? Oh, yeah. There you go. I didn't know that.
Yeah, they missed that one out when they were signing star signs.
So even though that is all not real, but it's funny to think about. So Ophiuchus is like an unintentional extra zodiac sign.
Exactly.
Zodiac constellation, actually, is a better way of putting it. Cool. So it's a snake bearer. What else is interesting? Like, what should I look for? What's exciting in Ophiuchus?
So Ophiuchus is, if you're looking for it, it's a tricky one to spot. It's kind of a rectangle with a pointy top. I recommend using a app on your phone that you could download, like the Sky Tracker app that can help you find constellations in the night sky.
Oh, okay.
Yeah. It also might help you find Barnard's star.
Barnard star?
Yeah. So Barnard star is the second closest star system to us. So you might know that Alpha Centauri is our closest star system.
Yep.
Well, Barnard star is the second closest star system at about 5.29 light years away.
Okay. How far is Alpha Centauri for comparison?
About 4 light years.
Oh, okay. Oh, so it's actually really quite close.
Compared with everything else in the universe, yeah, quite close.
Okay, so Barnard star, the second closest star to the sun, or the second closest star system to the sun, is in Ophiuchus. Mm-hmm. Yeah, I've never heard of that. Why aren't we telling the people about this?
Well, okay, it's a pretty faint star, so you might not really be able to spot it in the night sky, especially with all the light pollution we have in Perth. It can be difficult to spot. But it's still pretty interesting because it is the second closest star system, like I said. And actually, Barnard star is moving towards us. So at its closest point that it will ever get to Earth in about 9,000 years, it will be closer to us than Alpha Centauri is now. But that won't make it the closest star system because Alpha Centauri is also moving towards us, so it'll still be closer.
That's really cool. Okay, so I know I'm looking for the planets. I'm looking for Ophiuchus and maybe Barnard star if I have a telescope. Is there any other interesting space news happening in June? What's exciting?
Well, the winter solstice is coming up for us, of course.
Oh, the solstice. I keep hearing about the solstice. What does it actually mean?
So the winter solstice is the shortest day we have here in the southern hemisphere, and it'll be matched by the summer solstice that the northern hemisphere is experiencing with their longest day.
So what does solstice mean? What happens on the solstice?
So the sun has been slowly moving north in the sky each day. You might be able to track it if you watch where it rises each day. But on the solstice, it reverses course and starts heading back south. So if you watch sunrise after sunrise over the coming days after the solstice, you might notice the point where the sun is rising is heading further south.
Oh, okay. So like on any given day, the sun still rises in the east, sets in the west, but that literally the northerly location of the sunrise and sunset is going to start drifting back further south.
Exactly. And so you'll notice during the day the sun will appear further overhead in the sky until we reach our summer solstice and have our longest day during the summer.
Okay, and so I'm guessing this is closely related to the seasons?
Exactly. So that's why we have colder weather during winter, because the sun is lower in the sky, so it's coming in at an angle, whereas in summer it's right up above us in the sky and we have that direct sun shining on us, which is why it's warmer in summer.
Oh, okay. That makes a lot of sense. And so in some sense the solstice is an astronomical dead of winter or height of summer.
Yes,
not necessarily on the calendar, but just astronomically. Yeah, okay, that makes sense. All right, so we've spoken about some planets in the night sky and the morning sky, interesting constellation and the solstice, but let's leave Earth behind and go beyond Earth. Is there any interesting big news in the world of space right now? What's happening?
Yeah, well, the JUICE mission just launched last month in April.
The JUICE mission. Okay, you know what's coming next. What is JUICE?
JUICE is an incredible acronym for Jupiter Icy Moon Explorer.
Oh, okay, the Jupiter Icy Moon Explorer, which I'm guessing is going to be going to Jupiter.
Yes, exactly. And in particular, studying the icy moons of Jupiter.
Oh, okay. Who launched JUICE?
So it was launched by the European Space Agency on top of an Ariane 5 rocket, which you might remember was used to launch the James Webb Space Telescope a couple of years ago on Christmas Day.
Yes, I do remember that. Okay, so it's a spacecraft on its way to Jupiter to study the moons of Jupiter, not the planet itself.
No, NASA currently has the Juno probe in orbit around Jupiter, studying Jupiter itself. This mission by the European Space Agency is focusing on the icy moons of Jupiter, particularly Europa, Ganymede, and Callisto, and it's going to be looking at the subsurface oceans that these moons have.
The subsurface oceans of these moons. Okay, so why are oceans important? What's so exciting about water? Why do we go to Jupiter to study water at Jupiter's moons?
Well, as we found from living on Earth, where there's water, there is life. So if we ever find that there might be liquid water out there in our solar system, it's a sign that it could have the potential to host life. Even if life hasn't evolved there yet, maybe life could thrive there.
Okay, so it's basically studying the potential habitability of these moons of Jupiter.
Exactly.
Wow, that's really interesting. Firstly, how long is it going to take to get to Jupiter?
Yeah, it's going to take about 8 years, so it is a bit of a time to keep your eye on it before it's going to get to Jupiter, but it will do a flyby of Earth and Venus on its way.
Of Earth? Didn't it just take off from Earth? Why is it flying past Earth?
So the reason spacecraft might fly by planets, even our own planet Earth, is to do something called a gravity slingshot. So basically the spacecraft will fly into the orbit of the planet and use that planet's gravity to slingshot itself further into space. So it gets to speed up without actually using any fuel.
Oh, that's really clever. Okay, so it's not just like point the rocket at Jupiter and press the go button.
No, this is actually a lot more efficient in terms of fuel use to go to Venus first and fly around it.
Oh, okay, and like get a kick from its orbital speed.
Exactly.
Okay, and so when it gets to Jupiter, what's it going to do?
Oh yeah, so it's going to first get into orbit around Jupiter, and it'll do about 35 orbits of Jupiter, and it's going to be surveying the moons Europa, Ganymede, and Callisto before it'll then fall into orbit around Ganymede in particular. Again, that'll happen in about 2035.
Oh, wow. Geez, this is a long mission.
It is.
So I suppose 8 years to get there, so that's 2031. And so am I remembering correctly, Ganymede's the largest one, is that right? Yeah,
Ganymede's the largest moon in the whole solar system, actually. In fact, Ganymede is larger than the planet Mercury.
Oh, wow.
Yeah, so these are pretty big moons.
So if it didn't orbit Jupiter, would we call Ganymede a planet?
If it orbited the sun, yeah, probably. It would be able to meet the criteria for being a planet itself.
Oh, that's really cool. Well, you mentioned that they're studying the subsurface oceans, that JUICE is supposed to be studying that. How do we even know that these moons have oceans?
Yeah, so there's a few different reasons. The thing with studying something like an ocean on a moon this far away is that we don't get to just go out and take a photo of that ocean and see, oh, there's an ocean. We have to look at other ways we can figure things out. So, for example, with Europa, we can look at the surface of Europa and we see that it is shiny and it's frozen water, so it's an icy surface.
Oh, so it's made of ice.
Yeah, exactly. Europa's made of ice and it's all cracked over the surface though. So it's sort of like how Earth's crust is cracked. We have that rocky outer core and that's all cracked, and that's because we sit on top of a rocky mantle. There's this molten rock underneath it, and that's what causes that cracking in the surface of Earth.
Yeah, because the continent's all drifting around.
Exactly. So the same thing's happening on Europa. So instead of it being rock though, it's ice, and molten ice is of course liquid water. So we can then hypothesize that, oh, there's liquid water beneath this icy surface, and that's what's causing that cracking.
Oh, wow. Okay, so the secrets of the interior of the moon are essentially written on the surface. You just need to know how to read them.
Exactly.
Okay, so that's Europa. I think I'd read that Europa, somewhere in the back of my mind, was like made of ice, sort of covered in ice. What about something like Ganymede? Pictures of Ganymede, I think it looks like it's made of rock. How do you tell there's an ocean under that?
Yeah, so Ganymede's a little bit different. And well, the thing with Ganymede is, like we said, it's quite a big moon. Mm-hmm. In fact, Ganymede actually has its own magnetic sphere.
Okay.
Yeah. So what this means is that at its poles it has auroras like we have here on Earth, caused by our own magnetic sphere.
Oh, like the northern and southern lights?
Yeah, exactly.
On Ganymede?
Yeah.
Oh, cool.
So it has its own version of the northern and southern lights. But because Jupiter is nearby and it is massive and has a massive magnetic field, mm-hmm. Jupiter pushes the auroras on Ganymede back and forth. So they move back and forth along the moon.
And that's caused by Jupiter?
Yes, exactly.
Yep.
Now, because we know how big the magnetic field on Jupiter is, we can actually calculate how much the auroras on Ganymede should be moving.
Yep.
But when we look at the auroras on Ganymede, we notice they only move about half as much as they should be. So something's holding them back.
Oh, so it's like something's putting a brake on the magnetic field of Ganymede.
Exactly.
As Jupiter tries to push it around.
Right, and that something is the liquid inside of Ganymede. And it's having a pretty big effect. Like I said, it's halving the effect that the magnetic field of Jupiter should be having on Ganymede.
Yeah.
So we know that these aren't tiny little small amounts of water. These must be massive oceans, hundreds of kilometers thick. And to be affecting a magnetic field in this way, they have to be magnetic. So we can also predict that these would be saltwater oceans.
So they can conduct electricity.
Exactly.
Wow. And that, I see what you mean. So you'd need hundreds of kilometers of water to compete against the magnetic field of Jupiter. Mm-hmm. And we can see that. Yeah. Well, we can infer that by looking at the auroras.
Yes, we can infer that by looking at how the auroras change. So that's why we are now sending over the JUICE mission so that we can study these in further detail and get an up-close view of what's happening.
That's fascinating, that by looking at the auroras, which are on Earth some of the most beautiful natural phenomenon ever, but by looking at them on another moon, we can pull out secrets of what's actually going on hundreds of kilometres beneath the surface of that moon.
Exactly. Without even having gone beneath the surface of Ganymede, we can predict what's happening by looking at other things around it.
That is so cool. So has everything been smooth sailing then on this mission?
Well, okay, not quite. You know, it is literally rocket science. Sometimes things go wrong. Mm-hmm. Like, for example, when they were developing the RIME part of the JUICE mission, which is the Radar Ice Moon Explorer.
Oh, Radar Ice Moon Explorer, gotcha. RIME.
Yeah, so it's the subsurface radar that will actually be looking at these oceans. So it's a pretty important part of the mission.
Yep, and what went wrong?
Well, okay, so they have to fold it up to fit it inside the rocket ship, of course. But then the thing was, it wasn't unfolding, which is kind of a problem.
When it got to space.
Yeah.
Yeah. So is it stuck?
No, it's okay. They did a lot of testing and trying to figure out what happened, and then they managed to remove one tiny little pin that was stuck in there, and it did unfold. So we have solved that issue.
But that could have been a hell of a headache if they...
Yeah, it wouldn't have been great.
Well, all right, good. I seem to remember that was the big stress about the James Webb Space Telescope, is that it was folded up as well, mm-hmm. and was essentially a miracle that it actually even worked when it unfolded.
We don't call it a miracle, but we were very pleased to find out it did unfold. It was a lot of years of work that went into that.
Yeah, right. Now, have just remembered from the back of my mind, the Ganymede and Europa and Callisto, they're called the Galilean moons, aren't they?
Yes. So there are actually 4 Galilean moons. Because there's also Io, of course.
Io, that's right.
Yes. But these are the 4 largest moons of Jupiter, and they are called the 4 Galilean moons, of course, in honour of Galileo, who did discover them.
Oh, of course. So does Galileo get a thanks for any of this?
You know what he actually does? He gets a little plaque on the side of the JUICE spacecraft.
Oh, really?
Yes.
What does it say?
It is the first 3 pages of his book. So you can look it up and you can read the first 3 pages on his book about the discoveries of the moons.
Oh, that when he first discovered them.
Yes, the 4 Galilean moons. Of course, now we've discovered about 95 moons around Jupiter. But these were the biggest ones.
Yeah, okay. Yeah, I seem to remember a lot of the new ones are like just small little potatoes and things like that.
Yes.
Well, potato-sized,
Potatoes.
potato-looking objects.
Yes.
They're not well-formed moons.
We might have to study them as well and see if they are made of potato. I don't
imagine they might be made of rock or something. All right, so you mentioned that the European Space Agency is in charge of JUICE. Is NASA doing anything at Jupiter as well?
Yeah, so NASA does currently have the Juno probe in orbit around Jupiter. So that one is focusing on the planet Jupiter itself, not so much the moons. So that's why the European Space Agency is sending JUICE to have that focus on the moons of Jupiter.
Okay. Yep, yeah. A complement, basically.
Basically. And NASA, in a few years, also hopes to send up the Europa Clipper, which is going to have a similar purpose, but it's going to go into orbit around Europa. So it hopes to complement, again, the JUICE program that's looking at Ganymede primarily, and this one will be focusing on Europa.
Oh, okay. So the 2 sort of most promising water worlds out there.
Exactly.
I just had a thought. If the oceans of Ganymede are like hundreds of kilometres deep, does that mean that Ganymede potentially has more water than all of the oceans on Earth?
You know, I hadn't thought about it before, but yeah, the oceans on Earth are only tens of kilometres deep. So even though Earth is a lot bigger than these moons, the water on these moons is more equivalent to our mantle. So they would have more water than here on Earth.
Wow, that's a stunning thought.
Yeah, there's a lot of water on them.
I'd never really thought about it like that. That's fascinating. So really the moons are the real treasure of the solar system. The planets are like an interesting afterthought.
Yeah, I suppose we can think of it that way.
All right. Well, this has been a time and a half. Thank you for being here, Amanda. I've really learned a lot about the night sky this month and the Jupiter Icy Moon Explorer. Thank you so much for being here.
Ooh, thanks for having me.
That's it for this episode of Particles. Please look up. We'll see you next month when we talk about the night sky and the space news for July. If you want to hear more interesting space news, check out the website particle.scitech.org.au for more information.